Hello everybody and welcome to my channel. Today we're going to be talking about the basics of cooking, which include time, temperature, and the timing of seasoning and flavoring your food. The following episode will be about dry cooking methods, and then the third episode in this three-part basics of cooking will be wet methods of cooking. But today we're just focusing on heat and timing and flavoring. So let's get started. Alright, so first of all, there's going to be some terminology in the beginning and then we'll get to the flavorings and seasonings. Because first we're going to talk about a little bit about the science of cooking. Now, like I've mentioned many times before, baking is more of a science than cooking, but cooking is still a science. Cooking is simply the transfer of energy. Cooking destroys microorganisms in the food and can make food easier to eat and digest. Basic understanding of the scientific methods of cooking helps a cook achieve success in the kitchen. To know cooking is to understand what cooking methods work best for your food type. To know and understand cooking helps you understand why foods react a certain way when heat is applied, and what cooking transfers bring out different textures, flavors, appearance, and aroma of a food. So basically, if you understand basic cooking methods and what different types of heat transfers do what, your success in the kitchen could improve. So foods are comprised of protein, fat, and carbohydrates, which are known as macronutrients, and vitamins and minerals, which are known as micronutrients. Food also contains such things as pigments, water, and flavor elements that interact with heat transfers. So the next part we're going to do is just some basic scientific cooking terminology. First, we're going to talk about heat versus temperature, and those are two different types of scientific terms. Heat is an energy and the result of motion of atoms and molecules, which is then transferred. Heat is a measure of how many different atoms there are in a substance, multiplied by how much energy each atom possesses. So temperature is a measure of heat energy. Temperature is the average of total energy in a given system via heating. Temperature is related to how fast the atoms within a substance are moving. There are also different kinds of energy, and the first type of energy I'm going to talk about is thermal energy. Thermal energy is the atomic and molecular particle movement within a substance. One type of thermal energy is conduction. Conduction is the exchange of thermal energy between a heating element and a food. Conduction is an important, albeit slow, method of heat transfer from the exterior of a food to the interior of a food. Next we have convection, and convection is the transfer of energy through a fluid or gas. There are two types of convection. The first is natural convection, where heat is transferred from the movement of molecules in either gas or liquid, which circulate as warmer temperatures rise and cooler temperature areas sink. The second type of convection is called mechanical. Mechanical convection is achieved by way of fans and ovens or stirring to circulate heat more evenly. The third type of heat transfer is radiation, and there are three types of radiation. Radiation is the transfer of heat through waves of pure energy. Radiation does not require that the food interact directly with the heat source. Grilling, where the heat is above the food, and broiling, where the heat is below the food, are two forms of radiation cooking. In radiation cooking, the interior of the food is still heated by conduction of the heat from the surface into the interior. Types of radiant heat include infrared, which uses an electric or ceramic heating element at such a high temperature that it gives off waves of radiant heat. Toasters and broilers and hot coals are examples of infrared heat. Microwave is another form of radiant heat, and induction. Induction is a type of instant radiant heat. The method of heating involves transferring currents from an electromagnetic field located below the gas surface directly to the magnetic induction cookware placed above. Induction is a type of heating that utilizes magnets and does not require the need for a flame or burner. Induction is probably the least known form of cooking in many places. The only time I've ever used an induction appliance was in culinary school. They tend to be very expensive. I have done some videos where I've talked about induction cooking, specifically in an episode where I talk about gas versus electric. And that link is in the description if you're all interested in gas versus electric and a little bit more about induction cooking. All right, we're done with the science, mostly. We're going to talk about cooking times and the best way to determine how long your food has to be cooked. Cooking times are determined by a number of different factors, and they include temperature, both temperature on the stove and temperature of the environment around you. They include the speed of heat transfer, so how much heat is applied to the food. Other factors that impact cooking time include elevation. The higher the elevation, the longer it takes to boil water. Other elements that impact cooking times are the size and the texture of the food item you're cooking, as well as the characteristics of the food item you're cooking. Other considerations for determining cooking time are your appliances. So it's important to understand the variations that can exist between ovens and fryers and steamers, and also considerations including their accuracy overall and the last time they've been calibrated. At the end of the day, cooking times really vary, and it's up to the cook to understand their equipment and to understand the food item that they're cooking, and also to understand what that food looks like when it's done cooking, whether it be to the touch like with a steak, or whether it be visually like with a boiled potato. It's very important to understand your food, and part of that is understanding cooking methods. Next, we'll be discussing when to add seasonings and flavors within the cooking process. We'll be discussing flavorings and seasonings in much more depth in the future, so for now, the timing of flavoring and seasonings is just like a footnote. Successfully seasoning and flavoring your food comes with experience and judgment based on understanding seasoning and flavoring types, quality, and timing. So there's a difference between seasoning and flavoring. And seasoning is used to enhance the flavors of the food rather than mask it or change it. As you would guess, salt is the number one seasoning in the kitchen. Seasonings include salt and pepper and acids such as lemon juice and vinegar. Flavoring is adding a new flavor to a food, changing or altering the natural flavor of the original ingredients. In some cases, there can be a very subtle difference between seasoning and flavorings. For example, pumpkin pie spice blends, almond, anise, celery, cassia or cinnamon, clove, lemon, nutmeg, orange, rosemary, savory, basil, sweet marjoram, thyme, and wintergreen. Nutmeg is an example of a seasoning and a flavoring. Normally used for its distinct flavor, a small amount can be used to perk up the flavor of a cream sauce without being detected. So that's the difference between flavorings and seasonings. Seasonings enhances, flavorings change. It's a very basic way to look at it, but it's the easiest way to look at it. Next, we'll be moving on to when to add your seasoning or flavoring to your dish. For liquid dishes, seasonings should be added at the end. Salt and other seasonings should be added at the beginning, especially when large pieces of food are involved, where the salt and pepper may not have time to penetrate or absorb or blend into the dish properly. Adding seasoning along the way can be crucial to the success of a dish, but you have to be very careful, because if you're cooking a liquid like a soup and you salt too early, as the liquid evaporates, it concentrates the existing liquid, and that concentrates the seasoning, and that's how you end up with a really salty dish, which sometimes can be easily rectified by adding maybe some extra stock or some cream. You have to be really careful not to put too much salt in the beginning of the cooking, but along the way is very important. Next, we're going to move on to flavorings, and if you remember, flavorings aren't for enhancing, they're for modifying or changing the existing flavor of the item that it's being applied to. Flavoring can be added at any time depending on cook time, the process, and the flavor ingredient being added. Super simple, hey? It's very vague. Only a few flavorings are successful when added at the end of cooking, and those include fresh, not dried herbs, sherry or flamed brandy, and condiments such as prepared mustard or horseradish. Most flavorings need heat to be released and have time to blend. Whole spices take longest. Brown spices release more quickly. Prolonged cooking can result in loss of flavor. Most flavors, whether spice or main ingredient, are volatile, which means they evaporate when heated, which is why you can smell them in the cooking process. So next we're going to talk about the effects of heat when applied to a food item. And there are 5 different main effects that heat can have when applied to the surface of a food. And the first one of those is caramelization. Caramelization is the term for cooking sugars. Only food cooked via dry heat methods can reach the temperature required for caramelization. The use of simple carbohydrates are very important in the act of caramelization. Some examples of caramelization can be found in braised foods, where the exterior becomes brown and crispy, the top of brown bread, and different types of desserts. Caramelization is responsible for most flavors associated with cooking. The second one is coagulation. Coagulation is the term for cooked protein. Coagulation is the irreversible transformation of proteins from a liquid to a semi-liquid state to a solid state. Coagulation is completed at between 160 and 185 degrees Fahrenheit, or 71 and 85 degrees Celsius. Examples of coagulation can be found in cooked meat fiber, egg whites, the gluten development in baking bread, and rennet coagulation in cheese making. The next term is evaporation. All foods, whether cooked or uncooked, contain moisture and are susceptible to evaporation, whether naturally or artificially. Evaporation happens 2 ways, either naturally, like with fruits and vegetables that slowly lose moisture over time, or through the process of cooking. The fourth term is gelatinization. Gelatinization is the term for cooking starch. Starches are complex carbohydrates found in plants and grains such as potatoes, wheat, rice, and corn. Gelatinization is the transformation of starches into bigger granules through absorption of liquid. Gelatinization generally occurs at 150 to 212 degrees Fahrenheit or 66 to 100 degrees Celsius depending on the starch. Items that gelatinize are often used as thickers. Examples of gelatinization includes when flour in a cake batter absorbs water from the other ingredients added, such as eggs and milk, and then gelatinizes. The fifth effect of heat on food is melting. One important thing to note that fat melts when heat is applied, but does not evaporate, except for in the case where there may be water in the fats, such as with margarines or any other blended oil spread products. While fats will not evaporate, most fats can be heated to very high temperatures without burning. So that's it for heat, temperature, and seasoning timing. I hope that this video was a little bit helpful. It's going to be the base of the next episode, which is dry cooking methods, and so we're going to be talking about specific cooking processes. Most of, I am sure, you're very familiar with, but we're going to dig a little deeper into the actual processes. Thank you for stopping by today and watching my video. If you haven't watched any of the other content from the Culinary Bootcamp series, please take a look in the description below. I started a playlist and it should start from the beginning all the way up to this video, or you can just watch them here and there randomly in whatever order you want. But I recommend following them from the beginning, because we're layering information, we're layering knowledge in order to move on to actual cooking and understanding. So with that said, I hope you enjoyed this video today, and as always, I hope you have a wonderful day.